Today we are going to go over section 4.2, which covers function notation. Make sure you copy the notes down. I'm not going over those word for word, but we'll work through some examples, hopefully help you out as you're going through this section. So function notation is just a way of writing an equation. Hopefully you recognize f of x. F of x is the same thing as y, so that's really what function notation means. There's lots of different ways to write equations. All of these things mean the same thing. They all tell you to take x, multiply it by 2, and add 3 to get y. Most common forms that we're going to come across is either y or f of x. So that's what we're going to look at in this section. The reason we use f of x is that it's really a shorthand way of letting us substitute in for x. So when they replace the x with a number, like in this case 5, they're asking you to go to the equation, take x out, and put in 5. So as you can see in these examples, they want us to plug in 5 here. They want us to plug in -2 here, plug in 0 here. They can even plug in variables as well. So they tell us to take x out and put in a plus 2 in its spot. So for a few examples, in this first one, they're asking us to take x out, put in 3, and then solve. Make sure you follow order of operations and all of your regular math rules that you would. So in this case, for f of 3, we would take out x and put in 3. From there, it's just simplifying. We don't really worry about the f of 3. We just leave that in the problem. That told me that I plugged in 3. And in this case, I would take 21 divided by 3 to get 7. F of 3 would be 15. In this next example, they ask us to find f of 6. So we're going to take out x, plug in 6. Remember, these are absolute values. So once we do the operation inside the absolute value, we just take the positive version of that. So f of 6 tell me to take 5 times the absolute value of 10 minus 6. Working inside then, f of 6 would be 5 times the absolute value of 4. Absolute value of 4 is 4, so 5 times 4 then would give us 20. Once again, if they put a variable inside, like this next example as 8w plus 3, we still take x out, and we put everything in that parenthesis in its spot. In this equation, we have -3 times what we're putting in for x, which is 8w plus 3, and then we still have that -1 at the end. And distribute the -3, giving us -24w, and then plus -9. Still have that -1 at the end. Now we can combine our like terms at the end. Get -24w minus 10. Second part of this function notation asks you to look at graphs. Basically do the same thing, but they've already done the work for you because they've already plugged in. You just have to recognize where to look on this graph. So if they ask us to find f of 0, they're telling us x is equal to 0. They want to know what the y value is at that point. So go along your x-axis to 0, find that point on your graph. In this case, we would get 3. If they give you the final answer and ask you to find x, then you just want to go to that y value, because remember g of x is the same thing as y. So I'm going to go on the y to 4 and then find what x value would have that same point. So here the x value would be 9. But just be careful which way they want you to go. If they plug in something for x, go along the x-axis to that number, find the point. If they give you the y value and ask you to find x, go the opposite direction. Last thing to be careful about is on a graph, if there are an open dot, it's not equal to that point. If it's a closed dot, it is equal to. So if they want us to find f of 0, we would go to 0 on the x, and then as we go down, we notice there are 2 points on our graph. However, this one is open, so it's not -8. This one is closed, so that's the one it's equal to. So in this case, f of 0 would equal -4. Hope that helps as you go through these problems. As always, feel free to email me or record a Flipgrid with any questions that you have, and I'll get back to you as soon as I can.